All right, so standard deviation. This is a weird one, but, and don't write this down. Let me just get in fact, I'll just write on the back of our formulas to kind of explain this concept. Don't write this down, please. If I were to say the average everyone got on our test was a 75, what would you assume if I picked a random person in the class? What would you assume their score was? 75. But what if half the kids got a 50 and half the kids got 100? Well, that would average to a 75, wouldn't it? But if I grab a random student, I would say, what's your grade? 50. What does that average do for me? It tells me what the middle number is, but that doesn't tell me much about the individual values from that set of data. This is where standard deviation comes in. Let me give you a better example. Let's say 10 people took a test. And let's say 9 of them got 20s. Again, don't write this down. 9 of them, says 4, 5, 6, 7, 8, 9. 9 of them got 20s on this test. And let's say one kid had a bunch of extra credit saved up. It's like, you know what, I've been doing all the extra credit. I read like 3 extra engineering books, wrote them essays. I did all kinds of extra credit. And he got an 800 after he added up all his extra credit. Just for the sake of argument. What would be the average? If you add up the 20s, 20 times 9 is 180. 180 plus 800 would be 980 divided by 10. We get an average of a 98. Is that average very helpful? The average is a 98, but most of the data values deviate pretty far from that average, or, if I may, standard. Standard deviation is how far the data values deviate from the average. Intro to standard deviation. Let's start by saying I took the average height of students at the high school. Now, let's say that this average, and by the way, guys, the Greek letter mu, I'm going to put that in parentheses. It looks like this. It looks like a U with a little tick in front of it. It's the Greek letter mu, means average. I'm going to write this in red a couple times so y'all can see it. Do you have to write this down? No, of course not. I just want y'all to see what it is. It's the variable for average. Let's say I found the average and I got 5 feet 6 inches. What would that make it in just inches? 66 inches. So our average, or mu, is 66 inches. Do y'all see this formula that y'all picked up when y'all walked in? There's 5 steps to it and there's 2 versions. We will look at these in more detail tomorrow. Don't stress too much about how to calculate standard deviation. Let's just talk about what it is after we've calculated it. Let's say we calculated our standard deviation using this formula. And let's say we got one standard deviation and this is represented by the Greek letter sigma, which is just a circle with the line coming out the top. And let's say we got for one standard deviation was 3 inches. Here's the deal. Is every year I have a kid ask me, where did I get those numbers from? So let's go ahead and answer that question right now. I'm going to write 2 big parentheses for myself. Where do the numbers to the left come from? I'm going to make this very simple for all of you. I'm going to write it in all caps. We made them up. What is the standard deviation? Well, if I were to say if I wanted to know what one standard deviation is, this is a little complicated, but we are going to deviate from the standard one time. We are going to take our average, which is the standard, by the way. If you haven't figured it out, the word standard and average mean the same thing. And we are going to both add and subtract our standard deviation, which is just a circle with a line on top of it. That's the variable for standard deviation. So take the average and both add and subtract the standard deviation. What is the average again? What did we say? 66 plus or minus. What did we say the standard deviation was? 3. Okay. What is 66 plus 3? And what is 66 minus 3? 63. So our range of values would be 63 to 69. One standard deviation, if you take the time to calculate it using these formulas, which we're assuming we already did, correct? Would represent 68% of the population. What does this mean? It means if we look at all the kids at Austin High School, 68% of kids would be between 5'3" and 5'9". If I were to take 100 random kids at Austin High School, 2/3 of them, 68 of them, would be between the heights 5'3" and 5'9". Does that make sense? This is what standard deviation tells you. It tells you how far the numbers deviate from the average. Let me give you an example. Let's say I took the average shoe size of every person in America, and I got an average shoe size of 10. That's not very helpful, because if I then just make a bunch, like 100,000 shoes at size 10 and no other sizes, a very small percentage of the country would be happy with that. But what if I got the average shoe size was between size 7 and size 13 for 68% of the population? Do you see how that's a lot more helpful? This is what standard deviation tells you. 68% of my population are between the heights of 5'3" and 5'9". Let's go a step further. Let's go to 2 standard deviations. What I do is I take my average and I both add and subtract 2 standard deviations. What does that look like? It looks like our average, which is still 66, and I add and subtract 6. So our new range of values are between 60 and 72. 2 standard deviations represents 95% of the population. Where am I getting these numbers from? 68 and 95. 68 and 95 are constants with standard deviation. 2 standard deviations, if you calculate it, will always be 95% of whatever you calculated. The rule is 2 standard deviations represents 95% of the numbers. What if we were to go 3 standard deviations? Well, that would be mu plus or minus 3 sigmas, which would be 66 plus or minus 9. This would be 57 inches, or 4'9", all the way to 75 inches, or 6'3". Once you've gone 3 standard deviations out from the average, this represents 99.7% of the population. This should have been written in black. It doesn't matter to you guys, but it matters to me. And this should have been written in blue. It drives me crazy that I messed that up. 57 and 75. I want you to think about the height of every student at Austin High School for a second. Does it make sense that almost every kid at Austin High School would be between the heights 4'9" and 6'3"? So if I took 1,000 kids at Austin High School, only 3 of them would be taller than 6'3" or shorter than 4'9". Are those numbers believable? This is how standard deviation works. Why 99.7, not 100? Because there's always people that are a little bit taller or a little bit shorter. There's always what we call outliers, data values that lie outside the norm. This is how standard deviation works. It takes the average and it takes into account how far the values deviate outside the average. So let's put this in picture form. I want y'all to skip several lines for me, several lines. This is the last thing we're going to draw. And draw yourself a number line. And right in the very middle of this number line, let's write our average. What is our average? 66. And then, of course, this is 67. This would be 68. And 76. And I'll stop there because there's no reason to go any further. And then the other direction is 65, 64, 63, 62, 61, 60, 59, 58, 57, and 56. And again, I'll stop there. So this is 65. At 66, I would like you to draw yourselves 4 data values. Let's say I measured 20 kids, 20 random kids, 20 people in here, and I got 4 people at exactly 5'6". Let's say I got three people at 5'7", so 3 people at 67, 1 person at 68, 2 people at 69, 1 person at 70. No one in the classroom is 6'1", but I got 2 people at 6'2". No one at 6'3". I'm sorry, that's not 6'1". No one in the classroom at 5'11" or 71. 2 people at exactly 6 foot. No one at 73 or 6'1". And let's say I got 1 person at 74 inches or 6'2". Then let's go in the other direction. Let's say I got 2 people at 65 inches. 1 person at 64 and 63. No one at 62 or 61, but 1 person at exactly 5 foot tall. And that's it. That's my range of values. Now again, we said 66. That's our average, right? How much are we deviating from the average? What is our standard deviation? So I'm going to go up 3 and down 3. 1, 2, 3. So here, 1, 2, 3. Count, there are 20 values written down, if I'm not mistaken. 1, 2, 3, 4, 5. Ooh, I messed up. Hold on, let me check what I did here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm missing a data value. Let's add 1 to 61 just to keep our math consistent. Okay, guys? Sorry about that. I've got 14 values here in the middle here. I have 14 out of 20, which is pretty close. It's not exact, but it's pretty close to 68% of my values. 68%. If I were to go out a second deviation, that's add 3 more to the right, so that's all the way here to 72. And then 3 to the left, so that's all the way here to 60. That would be 19 out of 20 of my values. And 19 divided by 20 is exactly 95%. When I say that 2 standard deviations represents 95% of the population, what I mean is 95% of my values will fall in between the range of 2 standard deviations, adding 3 twice and subtracting 3 twice. That is the end of the notes. Go ahead and tape in this tape in at the end of your section.